Hello and welcome to my channel again. Today we're looking at the Maker Advent Calendar, day number 2. So we've come to the Advent page on the PiHut website, and we've got our application Thonny open for putting in our code. So let's click on day number 2. And let's also open box number 2 from our calendar. So yep, this is what we've got. So box number 2, we'll just pull that out. And in here today we have a little packet here with some wires in there. We've got 3 resistors and 3 LEDs. So let's have a read through and see what we'll be doing today. So welcome to day 2 of your 12 projects of Codemas Advent Calendar. Today we'll be playing with one of the most popular components for makers, LEDs. LEDs, light emitting diodes, are a staple component for makers of all experience levels, handy for indication, feedback, or just a bit of fun of blinking. LEDs, light emitting diodes, are a staple component for makers of all experience levels, handy for indication, feedback, or just a bit of fun of blinking. LEDs come in all sorts of shapes, sizes, and ratings, and are everywhere in our daily lives, in your PC, your home, your car dashboard, vending machines, spaceships, and more. Let's go. So box number 2. So we have a red LED, an amber LED, a green LED, 3 330 ohm resistors, and 4 male-to-male jumper wires. There we go, a little picture there. So today we'll be programming LEDs to light up, flash, and display sequences, building on yesterday's code, using GPIO pins to control them. We'll also be learning some new functions to MicroPython to introduce some of the new elements to your code. The box includes 3 different colors to allow us to have some fun making light patterns. So what is an LED? An LED is a light emitting diode. These components emit light when electrical current flows through them. Our LEDs have 2 legs, one longer than the other, as they have a specific polarity, which means that electrical current can only flow in one direction, and if not, the LEDs can be damaged. The long leg is the anode, the positive, and the short leg is the cathode, the negative. Current must always flow from the anode to the cathode, so be sure to read our wiring instructions below carefully to make sure you get this bit right. Resistors. LEDs usually require a current limiting resistor when using them with a microcontroller. Resistors limit the amount of current that can pass through a circuit, which helps avoid the LED trying to pull more current than the Pico's GPIO pins can safely provide, and equally protects the LED from too much current. It doesn't matter which side of the LED the resistor sits, as long as it's there limiting the flow of current for the entire circuit. Take a look at the comments section, for example. So here's the Raspberry Pi Pico pin map. Here's a simplified map of the pins on the Pico, known as a pinout. To help you with these next steps and the rest of the calendar, the numbers in the grey squares are the physical pin numbers, which are numbered in order around the board. The GPIO pin numbers, which we use in our code, are in green. You can also download the full PDF version here. So first, make sure your Pico is disconnected from the USB cable. So we'll do that by just taking the power out, and now it's disconnected. Breadboards. We're going to be adding components to our breadboard. Breadboards allow you to connect and prototype a circuit without soldering, using wires with pins at the end called jumper wires. These breadboards have 2 sets of horizontal channels. red and blue on both sides. All the red pins are connected, as are the blue. We use these to create rails of connections for us to use, such as ground for the blue channel and 3.3 volts for the red. The holes in the middle are connected in vertical lines, with each having 5 connected pins either side of the divider. The divider stops both sides connecting together. The circuit. Place the 3 LEDs in the lower section of the breadboard, one hole apart, with the longest leg to the right, as seen in the image below. Okay, let's get our LEDs out. Going to empty everything into the box so I don't lose anything. One, two, three. Okay, so longest leg to the right. So we're going to go into here. And then we're going to miss a pin out. Put that in there. And then we're going to miss another pin out and put that in there. So there you have it. Our 3 LEDs are installed into the holes, longest leg on the right. We now need to add a resistor to limit the current that the LED can draw from our GPIO pins. Place a resistor between the left leg of each LED and the lower blue channel, like below. We'll be connecting that blue channel to a ground pin shortly. Okay, so resistors. So I'm guessing it has to go in the right color. So looking at this resistor, I don't know if I'll get a clear shot of that, but there's coloring on there. And what I'm doing is I'm putting the orange that's on the resistor to I. Just like that. And I'll just make sure that they're all the correct way. Oops. And then I'll do that one. Excellent. So there we have it. We've got the LEDs connected and we now have the resistors connected also. So now we've got some jumper wires to use. Okay. Now grab the jumper wires. You need one wire connecting the blue channel to a ground pin on your Pico. So if we look back at the pin So we want this number 38, which is a ground, which is what they've highlighted here. So pin 38, ground. So that's there. To there. Excellent. Ground to negative. Okay, so then we're going to do pin 26, 25 and 24. So 26. Is there. And that is going to feed this leg of the LED. Same as that one for the next one. And same as that one. Okay, so we've got all our wires plugged in at the appropriate pins for the appropriate LEDs. Okay, so everything's hooked up. Let's code some Blinky. Activity 1. Light each LED. A simple exercise first. Some of the code we learnt yesterday, we're going to light each LED. Wait 5 seconds, then turn them off. To do this, we need to introduce a new module to you. Time. Okay. So the time module allows you to program delays in your code, making it wait seconds or fractions of seconds before continuing. It's another fundamental module you'll use in most of your projects. Our code imports pin again and also imports time. We then define the pin number for each color of LED and set them to outputs. After that, it's a simple case of setting each LED pin high, waiting for 5 seconds, using time.sleep 5, then setting them all low again. Here's the code to copy into Thonny and then run in the usual way by hitting the green button. Once you've lit each LED and know which color is which, unplug your USB cable and rearrange them to get them right in the right order of green, amber, red. So let's copy that code. Let's remove that and paste. Oh, I can't. I need to plug in the Raspberry Pi. So let's plug in the Raspberry Pi. And that's just connected. I've just got the ping. So now let's run it. And here we go. We have LEDs lighting up. Oh, yep, now they've gone off. So let's run it again. What colors are they? Amber, red, and green. Amber, red, and green. Amber, red, and green. Okay, and it needs to be green, amber, red. So green, amber, red. Right, I need to unplug the Pico again. Okay, so that one's amber, so it goes in the middle. That's green. And then that one is red. Let's get the cable. Let's get the cable and let's plug it in again. Okay, and there's the signal from, say, that the computer's picked up the Pi. Okay, click Run Current Script. And now we have green, amber, red. Excellent, in the right order. So this script is turning the pins on, and then after 5 seconds, it's turning the LEDs off. Okay, so now we've done that and we've got that ordered. Let's make things a little more interesting by making our LEDs flash. To do this, we need to introduce while loops into our code. Technically, you could just repeat the on-off code above, but that would make your code very long indeed and would eventually end. So let's look at a better way. We also need to introduce variables, indentation, and code commentary. So while loops. While loops are used to repeat a block of code as long as the condition remains true. Imagine you're bouncing a ball whilst your friend counts how many bounces you've completed. Your condition might be bounce the ball until you count 5 bounces. After 5 bounces, you would stop. We can tell a while loop to run a block of code until a count or certain condition is met. Or we can just make it repeat forever while using the while true, which is useful for projects intended to keep running. So we're now going to make our LEDs flash 10 times, then stop, and we'll show you how to do that in just a moment. We're also going to start adding commentary in our code examples. You can add comments in MicroPython code by adding a hash before the comment. This will be ignored by MicroPython. Adding commentary makes explaining your code easier to others, or even as a reminder to yourself when you return to a project. A number of weeks or months later, it's a very good habit to get into and allows us to explain each line clearly. Variables. A variable is just somewhere to store a value, a container, which we can also update when we want to. When we need to use the variable in a line of code, we just use its name. In our example below, our variable is called counter. We create this before the while loop and set an initial value of 1. In programming, a variable can be a whole number, a number with a decimal place, or a word text. Indentation. Our while loop says if the counter is less than 11, run the code indented below. Indentation is a gap at the front of the line of the code, usually a tab, space, or a number of spaces. It's very important in MicroPython as it tells Thonny that the lines belong to a particular block of code. In our example below, we've indented the lines under the while loop as the code belongs to that loop. The code below first imports the things we need as always, sets our pin numbers as we've done before, then creates a variable called counter, which we'll use to count how many times we've run the block of code. We start a while loop using while counter less than 11, which is while the counter variable is less than 11. Our code prints the counter to help us to see that value changing in Thonny, then simply turns all the LEDs off, then on again with half-second pauses in between. Without the pauses, it would be so fast that we wouldn't see the flashes. At the end of the block, we add +1 to our counter, then it starts to loop again. As soon as the counter variable reaches 11, the loop stops running and the program ends. Copy this code to Thonny and run it in the usual way, using the green button. So copy, paste. And then click run. Excellent. So you can also change the while loop to run forever. Swap the line out with the line below to give that a try. The counter will still continue to increase and print, but won't change what the code does. So change this out with while true. Okay, and then we will run the current script. So it's flashing, we're getting the count at the bottom. So now it goes just forever. Okay, activity 3, LED sequence. We're now going to make the LEDs flash one after the other in a sequence. Yes, like a festive decoration. Whilst there are more advanced ways of achieving this, using lists, for example, which we'll cover in a future box, we're going to keep things simple whilst we continue to learn MicroPython. The program for this is very similar. However, we need to change the LED control section to turn each LED on one by one, turning off the others as we go. So try the code below, paying attention to the off-on comments next to each LED. Okay, so we've got that copied. And we're going to run that script now. 1, 2, 3, 1, 2. Okay, excellent. So it's flashing each LED. And it's done that 10 times. Fantastic. So that's day 2 complete. Another great day of learning how to code with the Raspberry Pi Pico and MicroPython. Today you have created your first circuit, learned how to use the time module to add delays to programs, learned how to use while loops and conditions, learned about variables, learned about code commentary, and created dashing, flashing sequence of LEDs. Please do not disassemble the circuit as we're going to be using it again with the contents in the next box. See you all tomorrow. Well, that's great. That's day 2. Brilliant. See you tomorrow then.